Hi folks, so in this video what we're going to be doing is completing a problem here based on the ellipse. It's a question from the World of Graphics textbook, page 185, the problem based on the egg cup. And if we look at it here, it says here, question number 2, 185 of the World of Graphics textbook. It is important to eat a good breakfast like a boiled egg before going to school. A boiled egg in an egg cup is shown below. The egg is based on a semi-ellipse, okay? So you can actually see the egg portion here. If you look at the egg, not the egg cup, but the egg portion. The egg portion of it is based on a semi-ellipse. So what does that mean, a semi-ellipse? Now, we've previously drawn an ellipse in a vertical position in class before, but essentially what does a semi-ellipse mean? It essentially means a half ellipse, okay? Like a semicircle, we've also got a semi-ellipse where we've got a half ellipse here. Use the trammer method. We're not going to be using the trammer method, we're going to use the concentric circles method. So use the concentric circle method to reproduce the diagram to the given dimensions below. Customized design of the egg cup, okay? So we're saying to add in a little bit of flair to that. All we're going to be doing is completing the problem, and if you want, after you've completed the problem, you can add in a little bit of customization to the actual egg cup itself. So first of all, we're going to start off by drawing in the actual semi-ellipse first of all. So you can see here we've got from the center point here of the semi-ellipse, okay, this direction here is actually the direction of our major axis, and then our minor axis is running in this direction, okay, because it's a vertical ellipse, or in this case a vertical semi-ellipse. It's not going horizontally, it's actually going vertically, like this one over here. So we have to take a bit of information off the sheet. So you can see here the length of our minor axis is 72, and then the length of half our major axis is 60. So that's the information we're going to take down. So I would always note these. My major axis is R60. My minor axis is a diameter of 72. Now, what's important here is, usually sometimes we'll be given the radius or the diameter, and you can see here we're given a mix of both. What we usually need is the radius. So if we have the radius, we're pretty happy. So I'm just going to highlight that one there. I'm going to be doing for my major circle a radius of 60. But for my minor circle, I'm not going to use the diameter. I'm going to use half the diameter. What's half of 30 or of 72 is a radius of 36. So that's what I'm going to be using for my minor axis. Okay, so there's the two radiuses I'm going to be using, the radii. So to complete this, what I'm going to do is I'm going to start off with a line in the middle of my page. Okay, I'm going to pick roughly about here as the center point. And from there, I'm also going to do a vertical line. Okay, now my radius is 60 for the major axis. So from the middle, I'm going to measure out 6 out to 0. And then also out to 36. So 36 out to 0. Okay, and using my compass now, let's get the wire onto the compass here. Using the compass, center point out to 60. I'm going to put in what is known as my major circle, but I'm only putting in half of it. And once again, my minor circle, once again only putting in half because we're completing a semi-ellipse. Now, some points to note. This one here is my major axis, okay? So what I often do is I write out here what's the direction of my major axis. So MAJ stands for major. That is going, in this case, it's going up and down. So at the top of the major axis is a point on my ellipse, okay? That is a vertex. Then let's note the direction of the minor axis. MIN stands for minor. In this case, our minor axis is going left and right. So major axis is going up and down, minor axis is going left and right. And the minor axis is where the minor circle finishes. So you can see here, here, and here. So our ellipse is going in this direction. So what we have to do is we have to find a series of points that are going to be help us. We can't just obviously connect there. We need a couple more points there to actually create a smooth curve. So the method we use is concentric circles. So we're going to split it up into 36 degrees. So 30 degrees to the left, 30 degrees to the right, 60 degrees as well, and finally 60 degrees once more. Okay, so there you have it, guys. What we're going to do now is we're going to use the divisions method. So if I treat this like a clock, this is number 1, this is number 2, this will be 10 o'clock and 11 o'clock. If I just take the number 1 o'clock one, okay, so let's take this division line. Now the method is, wherever it cuts the minor circle, we go parallel to the major axis. Wherever it cuts the major circle, we go parallel to the minor. So you can see here where my division line number 1 cuts through the minor circle, I want to go parallel to the major axis from this point. So let's note the major axis, it's going up and down. So from here, I'm actually going to go up. Okay, so that's the method. Wherever it cuts the minor circle, we go parallel to the major axis. So I'm going up from there. Now, with the same division line, where it cuts the major circle, I'm going to go parallel to the minor axis. In this case, the minor axis is either left or right, and from here, I'm going to be going left. Where the two of those cross over, gives me a point on my ellipse. Okay, so I want to apply the same method to all the other division lines. So for the number 2, where it cuts the minor circle, I'm going to go parallel to the major axis, up or down. In this case, it's always going to be up. And where it cuts the major circle, parallel to the minor axis, left. Want to get a bit quicker now. Okay, so you can see here, anyone where it cuts the minor circle, I'm going to go up, parallel to the major axis. And anywhere it cuts the major circle, I'm going to go, in this case, right, parallel to the minor axis. And what you can note then is a series of points that are on our ellipse. So really quickly there, sketch in between the points, trying to make the curve flow as smooth as possible. And when you have that done, as best you can, just do it in one continuous path. And there we have it, okay? And as far as I know, I think I also have to heavy in that line. There is our semi-ellipse. Now, to complete the rest of the problem, it's simply a case of putting in the rest of the measurements. You can see here from this semi-ellipse, I'm going to go out 6, and then down 36 as well, okay? So, from here, I'm going to go 6 out to the left, and 6 out to the right. And from these 2 points then, go down, down, and then I'm going down, I think it was, I just got to check there, it's down 36 and then another 36, and if you see 36, 36 and 24. Okay, so I'll actually put all those in now, so I'll actually go down a bit further. So, it's down 36. Down another 36, and then I think it says 24. So I'll mark that in. There's the 24. Okay, put these in, and this one in. Okay, and now what I'm going to do is heavy in this portion. So I know this is heavy from there down to there. In these little sections here and here. And now what I have to do is I have to get the middle of this, and from what I can tell, it's 72 plus 6 plus 6, it should be 84, yeah, 84, and half of 84 will be the 42, will be the radius. That's the middle. Okay, and you can see there, the reason I got that, if you see, after we went out 6 and 6, continued that straight down, actually, that's what I should have done, and I have a radius of 42 to be able to draw on that arc. Okay, so to get that, check it first here. Probably should, as I said, just have brought this one straight down. You can see it's matched up there. And now, always just check it beforehand. Yeah. Okay, now that I've done that, just a look here. Now what's important here is if you follow from the edge of the ellipse, or this point here on the minor axis, if I follow this down all the way to the bottom, it'll connect up to there, across and down, and the same on the opposite side. So to complete this problem, from this point on the minor axis, down and down, and these points here, this one connects up to here, and this one connects up to here. And what you want to do then is simply heavy in the rest of the information. So that's that one, and then this one. So I'll heavy in that, then just using the compass to heavy in the arc. So there's that portion and that portion. And there you have it, guys. That there is the problem completed. World of Graphics page 185, the egg cup question here based on the ellipse, and it's when we have an ellipse in a vertical position and it's a semi-ellipse because we're only drawing half of the ellipse, okay, or in this case half of the egg. Okay, that's the question done there, guys. I hope you found that helpful.